Hey everybody, I just wanted to take a little time and go over some sample problems here. So in this case, let's take a look at 14.27 in the Brown-Lemay and Burston book. Okay, it says a reaction A plus B reacts to form C, and it's given this rate law. Okay, and so the rate law is R equals K, and then it's B squared. Okay. Now, the interesting thing here is that it says if A is doubled, how will the rate change? Well, this is a relationship that we can look at just using the rate law. Okay. Now, is the rate is symbolized here by R, is the rate dependent at all on the concentration of A? Okay. According to the rate law, it is not. So no matter what we do to the concentration of A, it is not going to change the rate. So even if we make this 1,000,000 times bigger, the rate is not going to change. Okay, it's only when we change the concentration of B that that's going to change. Okay, so what happens if we, how will the rate change? It won't. Okay. The second question is what happens to the rate constant? Well, the rate constant is the same no matter what. That's going to stay the same. The only thing that can change a rate constant is if the temperature changes. And the temperature is not changing. We're only changing the concentration of A. So no matter what we do to the concentration of A or the concentration of B, the rate constant is not going to change. Now, the second part of this says, what are the reaction orders for A and B? Every reaction has an order, okay? And so here's, in the order of the reaction is in the rate law, okay? So maybe mathematically, we write this like this, that the order with respect to B, is equal to 2. Now, A is still in there, but maybe we say that the order with respect to A is 0, because anything to the 0 power is 1. So we could have, like our example up here, we could have this 1,000,000 times that. If we raise it to the 0, it's still 1, and then this is our rate constant. So if we wanted to, or our rate equation, if we wanted to know the orders, the order with respect to B is 2, and the order with respect to A is 0. Okay. Now, what is the overall reaction order? In that case, when we do the overall reaction order, whoops, look, I'm recording. When we do the overall reaction order is just adding these two, so 2 plus 0 is 2, okay, the overall. And that's fairly straightforward, okay? But then the question says, what are the units of the rate constant, okay? So to determine the units of the rate constant, okay, we have to set this equal. We have to set these things equal. We have to use the rates. So a rate, let's make sure that we have that. Okay, we don't have any time units, but we can make something up. So a rate is measured in, you ready for this? Moles per liter times seconds. It's the molarity change per second. It's how fast the molarity is changing. Equals K, whatever that rate constant is, times, now this is concentration of B, so the concentration of B is in moles per liter, but then we're going to square that whole thing, okay? And then if we wanted to, we could add moles per liter to the 0, but we don't have to because anything to the 0 power is 1, like we said in the last part, okay? So now, the point that we try to do, or what we're trying to do, is we're trying to get some unit for K to cancel out so that what's here equals what is here. Okay? So if we have a squared, how many moles do we have to get rid of? Well, K is on the same side of the equation, so we have to put moles on the bottom to get rid of one of the moles. And now we have 2 liters, so we have to get rid of a liter in order to get just 1 on this side. And now we have second, or some unit of time, and so we're going to put second on the bottom. So now what happens when we take that and multiply it by moles over liters squared? Let's see, liters, one of the liters cancels out, one of the moles cancels out, and now when we multiply that times this, you end up with moles per liter second. So determining the unit of the rate law is something that I think is valuable, and I think that this kind of equation with determining orders and stuff is helpful in a review. So I hope that helps out.